Today, I would like to share with you two case studies, what we have done in FCS research team. In this slide is an all-electric machine, and I'll be using an 8-cavity ice cream cart. And with a PP and 6 seconds in the cycle time and a 48 weight. So we know that in our industry, there's 5 elements you have to know if you want to get a good quality control. For example, first, machine. Second, mold. Third, material. Peripheral and processing parameter. Which means you have 5 elements, then if you have a better control, you will get a consistency in the quality. However, we know that in the circular economy, the material keep changing, which means recycle. So it's a big challenge for us. So FCS run some tests and ready. Another thing is more manufacturing tolerance. They are slightly, we have to beware as well. So in this case study, we have an 8 cavity. So we put sensor, we embed sensor in each at the end of the cavity. So during the injection, the filling stage, when they touch the sensor, they will give you a feedback. So a waveform will present. So in the slide, you will see the cavity number 8 and the 7 and 8, you will find that they are different with others, which means considered as a bad part. So, with knowing when there is a fluctuation in material, the sensor they will detect and they will identify. And you will know. After from time to time, they will accumulate losses in the production, 4,800 pieces. This is the problem we are facing. So FCS, we develop a technology. We want to solve this kind of problem. We have figured out an algorithm, so making our machines more smart. In this graph, you will see when the sensor being touched, they will different timing. During the time, they will show that they reach the sensor in a different time. So we start the algorithm. And you will see after few cycle, there will be automatic tuning and narrow down into the middle within the range. And you can see at here, this is the temperature that they being auto-tune themselves without any human involved. And all those cycles will keep monitoring 24 hours. So whenever they are slightly changing of the range, in the next cycle, they will be pulling back to the normal. So this is the big achievement and we are ready to commercialize. Our customer, they are ready to use. So as a conclusion, auto-tune in the process parameter, so we're able to do an online quality inspection. So this will give you a 50% increase in your quality rate. The next one I'm going to share with you, which is a melt variation additive control system. In this case study, we are using a PP with 2 cavities. Also, we embed the sensor in the cavity and feedback to our control unit. So imagine there's 2 results. We try to use MI with 60 and MI 55 material. So during the transition, you will see the weight of the part, they are changed rapidly. However, in our melt additive control, when we start the algorithm, and they're able to control the weights within the range. So even during the transition, there seems like no changing that much. So this kind of technology, they are very good when we are using a recycled material. They give you a weight without variation from 6 to 6.5 grams to 2.97. The process variation improved 55%. So what is the customer thinking? If you want to use a circular economy and we need a packaging, we need a solution that are ready for us to use. So out there, FCS customer, they are ready to use this kind of technology. So we have the opportunity to create a new chapter in the circular economy. We have a better opportunity, so let's create a better world. In below, this is our contact information. You can reach us or write me an email. You can contact us with a QR code as well. So we will have an expert to reach you at the moment. Thank you.